Some of this homework isn't going to be that big a deal. Some of it may be a little bit hair raising. Uh, if you know what composition is, you're not going to be scared about this lesson at all. It ain't going to be nothing. But if you don't remember what fog and goff are, or f of g and g of f are, then uh, you might want to listen to this lesson a few times until you get it. So, anyways, this part of the lesson it ain't hard. The algebra of functions is doing adding, subtracting, multiplying, and dividing, except with polynomials. So if I just have the numbers 5 and 3, because technically numbers are polynomials also. If I say 5 plus 3, 5 plus 3 is 8. If I say 5 minus 3, well, that's 2. If I say 5 times 5, that would be 25. 5 times 3, that would be 15. 5 divided by 3 is ugly. 3 divided by 5 is also ugly. But you see what I'm saying? Not a big deal. All right. So when I have polynomials like 2x plus 6, 5x plus 7, and I tell you add them, literally, you're going to take f, which is this one, f plus g. So you're going to put plus g. Now, is that a big deal? If I've got 2 oranges and 5 oranges, I've got 7 oranges. And then $13. Well, guess what? If I flipped these around, I would have the exact same thing. So why do it again? Work smarter, not harder. Now, I'm actually going to do G minus F because G is a lot easier. G is 5x plus 7. And then I'm going to minus each one of F, so that's 2x. And then minus 6 each piece, minus each piece. Now 2 minus, 5 minus 2 leaves 3 of them. 7 minus 6 leaves positive 1 of them. Now, the nice part about this is F minus G is the opposite of G minus F. So if that's positive 3x and positive 1, this is minus 3x and minus 1. The exact opposite. Now I like that. And I forgot to box these in. So why work harder than you have to? So these two are exactly the same. And these two are exact opposites. Now, f times f times f, I'm going to start right here. 2x plus 6 times 2x plus 6. I do these a little bit different than anyone else, okay? I tend to stack my like pieces. 2x times 2x, so 2 times 2 is 4. X times x is x squared. Now, 2 times 6 is 12. Keep the x. And now, 6 times 2 is 12 again. Keep that x. And 6 times 6 is 36. See, I stacked my like terms. An x with an x. Now, when I took an x times an x, I got an x squared. But an x plus an x, 12 horses plus 12 more horses, still gives me horses. It doesn't give me a donkey. It doesn't change what I get. It just counts how many I've got. Now I take f times g, so 2x plus 6 times 5x plus 7, so f times g. So this lesson is going to take a little bit. 2 times 5 is 10. X times x is x squared. Two times 7 is 14. Keep the x. Six times 5 is 30. Keep the x. 6 times 7 is 42. Combine my like terms. And remember, when I'm adding horses, counting horses, I don't genetically alter them. I just count them. So 14 plus 30 is 44. And a horse are still horses. So with E and F being so much work, shortcut your work wherever you can. Now I'm going to teach you a little trick. Now, it doesn't work for every problem, I'm just going to tell you. But it does work for some. 2x times x is 2x squared. Negative 4 times negative 3 is positive 12. Yahoo! So that means F times G equals H, which means F divided by, or H divided by F is G, and H divided by G is F. So let's shortcut our work wherever we can. So this one's G, this one's F, why do all that hard work if we don't have to? Just saying. Now, F times H, you gotta work for. And it's a lot of work. Oh, by the way, if I didn't know this trick on this one, you would have to factor this one. So all that factoring I told you about, and I told you it wasn't going away, guess what? It ain't going away. So 2 times 2 is 4. X times x squared. X squared is xx. That gives me 3 x's. So x cubed. This is a minus. 2 times 10 is 20. X times x is x squared. Now I got a plus. 2 times 12 is 24. Keep the x. Oh my goodness. Yuck. Now I've got a minus 4 times 2 is minus 8. And I've got an x squared. Stack your like terms. Negative times negative is positive. 4 times 10 is 40. Keep the x. Negative times positive is minus. 4 times 12 is 48. Combine your like terms. And at this point in the semester, your head is kind of broke. So I would definitely use Mr. Goodbuddy. If you owe 20 and you owe 8, you still owe, and you owe 28. X squared and x squared is still x squared. Here, that's easy because they're not negative. 64. That one's a little rough. Page next. Oh, yay. These are nice. These have zeros, or these have numbers in them. So this is a whole lot nicer to do. So put in 0 for F. So 2 times nothing minus 4. And then, and that says to times them. And then G, nothing minus 3. And stuff times nothing is nothing. So that gives us negative 4 times negative 3. So that gives us positive 12. Now, would I do this by hand normally? No, I would put it in a calculator. Now, 2 minus 3 over 2 times 2 minus 4. Uh-oh. Stuff over 0 is undefined or does not exist. If 0 is under, it is, if 0 is under, it is undefined. So then, number next. Put in 3 for G, and then 3 for H. So 2 times 3 squared minus 10 times 3 plus 12. Yikes. That's a little bit nasty. Okay, so that gives us 0 divided by 60. And Mr. Goodbuddy tells us that that is 0. So now that gives us 2 times 4 squared minus 10 times 4 plus 12 over, it's 4 minus 4. So now